Hi students, in this lecture I am going to discuss LC oscillations. Let us see. Consider an inductor and capacitor. So taking an inductor and a capacitor, this is a switch connected to an inductor. Initially switch was open and capacitor was charged, and it's a capacitance C, inductance of inductor L. Now we are closing the switch. That means initially energy was stored in the capacitor. It is electric potential energy. And once switch closed, charge on the plates of capacitor starts decreasing, right? That means if I'm taking, let us take now here that left plate as a positive and right plate negative. Now current flows like this. That means now capacitor is discharging. So capacitor is discharging means energy stored in the capacitor is given to inductor. Discharging means. Okay. So what happens is whenever there is a current flow, we are knowing that if current is changing, inductor opposes change in current. It is not opposing current, it is opposing the change in current. So an EMF is induced. And we are knowing that energy stored in the inductor is equal to half Li squared. So capacitor is now discharging. That means its energy is now given to inductor, right? And at one point of time, what happens is its entire energy will be given to the inductor. That means there is no charge present on the capacitor. That means energy stored in the inductor becomes maximum. Energy maximum means we can say half Li square, I value maximum. So when current becomes maximum, no charge on the capacitor, right? So next what happens is this energy is given to capacitor, and when charge becomes maximum, energy stored in the inductor becomes zero. Okay. So let us do one thing before making these conclusions. First take here Kirchhoff's second law for this loop. At one instant, suppose a charge on the capacitor is Q. Okay. Now see carefully. So we are moving like this anti-clockwise. So here what happens is the current increases up to one instant. So since current is increasing, it opposes the change. That means it tries to decrease it. Therefore, if you want to replace the inductor with a battery, and that battery must be like this. So high potential must be left side. That means this battery sends current left side because it has to oppose the change. Now it is increasing, so tries to decrease it. Okay, right. Now see how to take equation, and you can see EMF induced across inductor is L di by dt. Okay, right. So we are moving from high potential to low potential. So right here minus L di by dt, high potential to low potential. Next we are moving from low potential to high potential plus Q by C. This is equal to 0. Okay. Next, now you can see current equal to, this is minus dq by dt because capacitor is now discharging. Capacitor is now discharging means Q is decreasing. Therefore, dq by dt itself is negative. Negative of negative positive. Okay. Substitute this now here. Then see what we get. It becomes now L d square Q by dt square plus Q by C equal to 0. or I can write this one as d square q by dt square plus 1 by LC into q equal to 0. You can see this is of the form d square y by dt square plus omega square y equal to 0, where omega square equal to 1 by LC. So from this we can say charge is changing simple harmonically, right? So for this solution we can take it as q equal to q naught sine omega t plus 5. Okay. And if I differentiate this, then we get current, that is dq by dt, that is equal to q naught omega cos omega t plus 5. Now see carefully. Suppose I'm assuming that initially when t equal to 0, t equal to 0, charge is maximum. Okay. So T0 charge maximum means we can take 5 value 90. Okay. So total value is 90 initially. Initially 90. Initial 90 charge maximum. So Q naught, and coming to current 0. Current 0. Okay. Right. Now let us take this value is pi. This is now becoming pi. So omega t plus pi initially 90. After some time what happens? It becomes a pi. When it becomes a pi, charge becomes 0. Current becomes maximum Q naught. Sorry, this I naught. Okay. This is now 1/4 cycle. That means energy stored in the capacitor is a completely transferred to inductor. This is 1/4 cycle. Okay. Next. Now this omega t plus 5 changes from pi to, it is a 3 pi by 2. Means one more 1/4 cycle. Now what happens is charge will be maximum, current will be 0. Because 90, right? Cos 3 pi by 2, 0. This value. This is max, right? Modulus value. That means now this energy which is stored in the inductor, magnetic potential energy, is a completely transferred to capacitor. Right? Next. Now this becomes 2 pi. Then charge 0. Current is maximum. It is 1/4 cycle. Next, 2 pi becomes 2 pi plus pi by 2. Then charge becomes maximum. Current becomes 0. This is now one cycle. See carefully. Charge maximum. Next becomes 0. Actually, you can see here, if I'm not taking modulus value, this will be negative. Okay. That means on this split, if I'm taking plus Q naught, next 0, next minus Q naught, next 0, next it becomes plus Q naught. Okay, it becomes plus Q naught. Q naught 0 minus Q naught 0, finally Q naught. So this is now one cycle. So in this cycle, what happening is energy is transferred from capacitor to inductor. Next from inductor to capacitor. Next capacitor to inductor. Like this, energy oscillates. Energy oscillates in between these two. That's why name is LC oscillations. So in this, there is no loss of energy. Okay. So whenever charge is maximum, there current how much? 0. When current maximum, there is no charge, right? So we can use these equations while solving problems. And as we are saying, it is following simple harmonic motion. It's a frequency, or you can say time period of oscillations. Time period of oscillations t is equal to 2 pi by omega, right? It is 2 pi root LC. 2 pi root LC. This is time period of oscillations. Okay. Charge Q naught 0 minus Q naught 0 and finally plus Q naught. Okay. That is a focus now, a problem to get clarity. Right. See the question given. Two capacitors of capacitances C and 3C are charged to potential difference V0 and 2V0 respectively and connected to an inductor of inductance L as shown. The current in the inductor initially 0. Switch is now closed. In the inductor, the maximum current is. Okay. Right. Next, having two more questions. Okay. First, focus the first question. See how to start. Right. First, make the given diagram. So, given two capacitors, which are initially charged and connected to an inductor and having a switch here. Right. And you can see given values, potential differences, and given polarity also, which is very important. Plus minus C V naught to V naught 3C. Okay. Right. Now see what he's asking. Maximum current. So current maximum means di by dt will be 0. Right? That implies EMF across the inductor is 0 because it is equal to L di by dt. Right? That means across these two, what is the potential difference? It is 0. That means at this point and at this point, potential same. Right? Then see what happens. Now this I can take it as when current is maximum. If I draw a circuit like this, current maximum. So what happens is, first I'm taking here conservation of charge. See, this plate and this plate, these two are not connected to any other circuit. Okay, these two are now isolated. Therefore, sum of the charges on these two plates must be constant. See how much. This is a positive. 6CV0. 6CV0. And this is having negative. So minus CV0. That is the total charge on those two plates. And this must be a constant. So finally what happens is both having charge plus only, plus plus minus minus. Suppose the final potential difference across each, it is a V only because these two are connected. Here no EMF. That means indirectly these two are also having connection, means same potential. That's why same potential difference. Okay, right. Now see what I can write here. Charge on this plate, that is 3C into V. Charge on this plate plus CV. That means total value 4CV. Right. That means C gets cancelled both sides. This is a 6 minus 1, 5. 5 by 4. So V equal to 5 V naught by 4. That is the potential difference across each capacitor. Okay. Right. But we have to calculate what is the maximum current. So now what I can do is I can use conservation of energy. Relation is that here there is no loss of energy. It is just oscillating between inductor and capacitors, right? So writing conservation of energy. Initially, total electric potential energy half C V naught square plus half 3C to V naught whole square. This was the initial value. And if you take present value minus half, both having same potential. So I'm writing here 3C plus C into V square. V value 5 V naught by 4, right? Initially, this was the electric potential energy. Now this is electric potential energy. That remaining is now in the form of magnetic potential energy, half Li square. Or let me take it as I naught maximum. Okay. Throughout a half I can cancel. Next, what else? 2 square 4, 4 3 is 12. 12 plus 1 13. 13C V naught square minus how much it is? This is a 4. This is now 16. Remaining is a 4 here. So it is now 25 C V naught square by 4. That is equal to L I naught square. Right? Then see what we are going to get. So 13 fours 52. 52 minus 25, 27. 27 by 4 C V naught square by L, that is equal to I naught square. Right? That means it is 3 root 3 by 2 V naught root of C by L. That is maximum current. Right? Okay. Next, see what else we have to calculate. The potential difference across the capacitor of, wait, what is the question given here? Potential difference across a capacitor of capacitance 3C when the current in the circuit is maximum. So in current maximum means we have got a result here. Across each capacitor, potential difference is the same and that value equal to 5 V naught by 4. So very simple and direct one. So whenever you are solving any problem basing on LC oscillations, so first thing we can write energy conservation, right? Here we have taken that. Second, if you are given a combination like this, we can use conservation of charge because these two plates are not connected to any other circuit. That's why on these two plates, total charge must be constant. Conservation of charge. Suppose you are given, just imagine you are given only a single capacitor and inductor. Initially, capacitor was charged. Okay. So now asking like what is maximum current or what is maximum charge like this. So we got results Q equal to Q naught sine omega t plus phi. This is one equation. Second equation, differentiate this. That means if you are given like at what rate charge is changing, or if they mention how much current is flowing, then I can write here by differentiating this rate of flow of a charge, that is equal to Q naught omega cos omega t plus phi. So first thing they have to mention, suppose when time t equal to 0, some charge is given. At that instant, at what rate charge is changing, that is also mentioned. Then we get two equations and see number of unknowns. Q naught is not known, right? Phi value, that is not. So having two unknowns and two equations. Because coming to omega, it is 1 by root LC. Omega is known. So Q naught and phi having two unknowns. So if you are given only a single capacitor and inductor, you may expect me solving question like this using these two equations. Okay. So I hope you got a clarity.